Eric Burgess here. A random sample of the number of farms in thousands in various states are given in the table below. Estimate the mean number of farms per state with 95% confidence. Assume sigma is equal to 34. And then we've been given some data here. So we're going to do this two ways. We're going to do it using the calculator, and we're going to do it doing it by hand. So let's go ahead and dive right into this. So first up, we'll do the calculator way. So first, identify the problem. It says estimate the mean. So immediately we know that we are doing a confidence interval question because estimate the mean is a dead giveaway of that. So what we're going to do is we're going to come in here, we're going to hit on, and we need to put all these numbers in our calculator. So we're going to go to stat and then number 1 for edit. Now I've already got numbers in here. I'm going to clear the first list. So I'm going to hit clear while the list 1 is highlighted. And you see the list clears, and I'm going to push down. So it's being cleared. I'm going to put these numbers in. So we've got 49, 90, 58, 32, 60, 7, 13, 58, 10, 78, 9, 92, 4, 50. Okay, so we've got all our numbers in. There's 14 numbers. We've got 14 there. Let's just double check and just go back. This is always good practice. You're going to want to do this just so that when you do the question on the test, you're very confident you did it correctly. Okay, so it's all in there. We've checked it. We're going to go to stat. We're going to go over to tests. And there is an interval. We're able to get our intervals in here. If we come down, we see there's a z interval, a t interval, and there's also some proportion intervals. So we were given a population standard deviation. So we know it's going to be a z interval because of that. So we're going to come up to z interval and choose that one. So number 7. And in this case, we were given data. We were not given the statistics. So we're going to come over to data and hit enter. And then it's going to ask us for our sigma. So we have a sigma of 34. The list we put our data in, which is list 1. The frequency, you can just leave that at 1. And the confidence level is 0.95 in our case. And now we're going to hit calculate. Then it gives us the interval. So we found that the mean is somewhere between 25. Now these are in thousands, right? 25.76. And the mean's in the middle, and that's how we write middle in math. And then we say 61.38. So this is technically our answer, but we might say something like, what is the question one? It says various states estimate the mean number of farms per state. So we would say the mean number of farms per state is between, and then we would say 25.76 thousand, because remember we were in thousands, and 61.38 thousand. I'm spelling all weird now. That's how you'd write it as a sentence. So you'd give it the interval, you could write it as a sentence, and you're good to go. And that's all you have to do. Now let's go ahead, let's do the same one by hand. So you would go and look up the formula. You would identify, since we have a population standard deviation, that we need a z-score formula. So we would have the formula you would get would be x plus z of alpha over 2 times sigma divided by the square root of n. And I'm sorry, it should be a minus on this side. And then there's the mean in the middle. And then you have x bar plus z of alpha over 2 times the standard deviation divided by the square root of n. So we've been given sigma. We have n, but we don't have the mean. So we need to calculate the mean. So you can do that two ways. In fact, actually, I realize now we actually don't need to compute the standard deviation because we were given an assumed standard deviation. So that's really convenient. So here we've got a mean. Well, we don't know what that is. So we're going to have to take the mean of all these things And to do that, we just add them all and divide by the number of numbers. So you could do that. So you could add all these numbers up and divide by 14. Or you could come in and simply go to stat and one var statistics under calculate. So we're going to do that because that's just faster. We've already got our numbers in list 1. And we hit calculate. And it gives us our mean. So we have a mean of 43.57. You might do a couple more decimals of accuracy. And our n is 14. And we can I like to verify it just so that, it all matches up. So, all right, we've got everything that we need to plug into the calculator except for this z of alpha over 2. There's 2 ways to get this thing. So first we need our alpha. We are 95% confident, which means that our alpha, I'm going to put it down here with everything else, is equal to 0.05. Now we want alpha over 2 because we're going to split our alpha into half of it below, half of it above. And so that's going to be 0.025. Now you can do this by doing the calculator. And since we're doing a z-score, we just use an inverse normal because z-scores go with normal distributions. So we go to our distribution menu, second distribution. We go down to inverse normal number 3. And our area is 0.025. And since we're doing z-scores, we use a mean of 0 and a standard deviation of 1. So that's all fine. And we get negative 1.96. And it's actually going to be plus or minus 1.96. Because the distribution of a normal distribution is symmetric. So we could take the plus and minus and get this side too. And you notice the formula actually has it in there for us. It's already got the symmetry because there's a negative on this side and a positive on this side. So you don't need to worry too much about these signs. Now let's say that you wanted to find this using the chart instead. Well, we would look up this area and then find the z-score that goes with it. So 0.025. Let's go ahead and go to our standard normal chart. And we're just looking for 0.025. And there's actually a z-score that corresponds exactly with it. So let's see here. Here's 0.01. 0.027. We want smaller. Oh, here it is. 0.025. And if we look at the things that go with it, it comes across to negative 1.9 and 0.06. So we'd get negative 1.96, just like we got before. And we would say again that by symmetry, we would just take the positive and the negative. Now all we got to do is plug all this stuff into the calculator, into our formula, and then into the calculator. So 43.57 minus, and then our z of alpha over 2 is 1.96, times a sigma, which our sigma was given to us to be 34, thankfully, divided by the square root of n, which is 14. And then there's the mean. And then it's the same thing on the other side, except for now there's a plus sign between them. 34 divided by the square root of 14. And then to pop this all in the calculator, let's go ahead and do that. So it's going to be 43.57 minus 1.96 times, we want a fraction, so hit the alpha key and then F1. It's this secret button up here, and then you hit 1. And we have 34 on top and a square root, so the blue key and then the square root here in blue. And then 14. Push over until you're out from under the fraction and put a parenthesis. We hit enter. And look at this, we get 25.7, and let's compare that with our previous answer. And we get the same thing, so that's as expected. And let's go ahead and come up here and now change this to a plus sign. We just put plus, and we get 61.38, which is the exact same thing. So we would have the exact same answer, but this is how you would do it. Maybe your professor wants you to show your work, and that's all it really takes. So if you have any questions about this, let me know, subscribe, and we will catch you in the next problem.